Hey everybody, so we're right in the middle of week 6, which is the first week of module 4. So we should all be reading chapter 4 in the text, map, scale, and spatial reference systems. And this first week covers those first two sections, overview and map scale. Watch the lecture videos, participate in discussion 6, case law involving survey maps, which is due October 6th by 11:59 p.m. We're working on 2 labs this week. The first one is working with projections, which is the second tutorial at the end of chapter 3 in the text. And then working with scale, which is the first tutorial at the end of chapter 4 in the text. And both of those are due October 6th by 11:59 p.m. The Module 4 quiz opened on October 1st at 6 p.m. will be open until October 6th by 11:59 p.m. Again, those quizzes are, they can't be made up, and they can't be taken late. It's a hard deadline unless you communicate with me in advance if you think you won't have enough time to take the quiz within that given time frame. Okay, so I'm just going to really briefly go over what's upcoming for week 7, which is the second week of module 4. These slides will be up on Canvas soon, so you could review them in more detail, but the main point that I want to make is that we have another guest lecturer, Paulina Close, who is a GIS research data analyst with Caltrans. This is a really great opportunity for everybody to see what we have going on locally with Caltrans and how they use GIS for several different projects. So be looking for an email Friday evening with some different information about Paulina's presentation. I'll be including a story map, and that presentation is going to be this coming Tuesday, October 6th at 6 p.m. Again, these guest lectures are required. You will need to participate. If you cannot participate for any reason, you need to contact me in advance to come up with a solution for that absence. Okay, so let's go ahead and get into scale. So once we have chosen our projections and have our maps on that 2D surface, we need to then understand how to calculate distance on that flattened surface. So scale defines the scope of the map. The most simplified way to think about scale is how far in or out you are zoomed in on the map data. Is the map displaying a neighborhood block in the middle of Los Angeles, or are we looking at the entire city of Los Angeles? So when we're looking at a map, the scale bar or scale information, most of the time, especially beginning cartographers and map makers are using a scale bar. That's a really common way to display scale. We'll talk about the different types of scale here in just a second, but most commonly we see that. And again, that's tertiary information. The scale bar should be small. It should be inconspicuous and on the same level in that visual hierarchy as the north arrow and credits. So really your map reader's eye should be lying on that map data, which is what part of the primary information, and then the secondary information is that title bar and legend, and then all of the supporting information such as the scale bar and the north arrow, stuff like that should be small, and that the map reader should be looking for that once they have read the map data. Okay, also on small scale maps, the scale is only accurate in certain areas. Maps are described as either large scale or small scale. Large scale maps show a smaller amount of area with a greater amount of detail. The geographic extent shown on a large scale map is small. A large scaled map expressed as a representative scale would have a smaller number to the right of the ratio. For example, a large scale map could have a representative fraction scale of 1 to 1,000. Large scale maps are typically used to show neighborhoods, a localized area, small towns, etc. So large scale maps, highly detailed. As finished size is reduced, details become blurred. The examples that we have are reference maps, navigational charts, USGS quadrangles, and terrain relief maps. So this concept sometimes is hard to grasp because it's kind of the opposite of what you would think. You would think that a smaller area would be a small scale, but in fact, it's quite the opposite. That large scale means that we're getting more detail. Small scale maps show a larger geographic area with few details on them. The representative fraction scale of a small scale map would have a much larger number to the right of the colon, such as 1 to 1 million. Small scale maps are used to show the extent of an entire country, region, or continent. So again, small scale maps are less detailed, they're more abstract. As the finished size is enlarged, the map becomes more shapeless. So some examples, we also have thematic maps here, news maps, and maps for less educated audiences. Okay, so again, just a quick comparison between large scale versus small scale. So large scale, you have a large amount of detail, small number, and scale fraction. Small scale, small amount of detail, large number, and scale fraction. Okay, so we are going to look at some examples here. So here we have our large scale and our small scale. So we have increase of area, decrease of detail. And so for those, we're looking at that small or, relatively small number in the ratio, and then that relatively large number in the ratio. So large, small. So what is scale? The relationship between distances on a map and the same linear space on Earth. So most of the time we look at a representative fraction, we have that map distance over ground distance for our representative fraction scales. We also see that in the colon ratio. So there are three types of scale. Verbal scale uses a word statement to express scale. It's reserved for more casual maps where accuracy is not as important, such as tourist maps. Representative fraction is the relationship between the map distance over ground and is usually represented as a ratio, such as 1 inch on the map equals 10 miles on the ground. And then we have a graphic scale, which is usually a graphic symbol. We see scale bars a lot that represent ground distance on the map. Map readers can use this graphic as a reference when wanting to measure distance on the map itself. So we'll go into these in a little bit more detail. A verbal scale, again, uses a word statement to express scale. Verbal scales have mixed units because the statement will refer to the map using one type of unit while referring to the distance on the ground using another type of unit. For example, one may refer to a map that has a representative fraction of 1 to 63,360 using the verbal scale, 1 inch to 1 mile. The map distance uses inches while the ground distance uses miles. Thus, the units of measurement are mixed. A verbal scale is a user-friendly format that easily allows the map reader to understand the relationship between the map and the real world. So, verbal scale, this is useful to quickly convey to someone a sense of distance with which they are familiar. It's not good for maps which will be reproduced. And this is because that scale usually won't adjust if they're making a larger version or smaller version of the map. A representative fraction is the relationship described as map distance over ground distance, expressed as a ratio or fraction. A representative fraction is written using the notation of 1 over x or 1 to x, where 1 represents the distance on the map and x represents the distance on the ground. Because the representative fraction is a ratio, it is independent of any unit of measurement. For example, a representative fraction of 1 to 24,000 means that any unit measured on the map is 24,000 times that same unit on the ground. Therefore, 1 inch on this map would represent 24,000 inches on the ground. 1 centimeter on this map would represent 24,000 centimeters on the ground. In the book, they use an example that you can literally use any unit. And so they've used Oreo cookie to represent a unit of measurement. And so if we were to look at the slide here, this representative fraction would mean 1 Oreo on the ground would equal 211,200 Oreos, or sorry, 1 unit on the map, not the ground, the map, would represent 211,200 Oreos on the ground. And so, again, representative fraction is just map units to real life ground units. It shouldn't matter if you're talking about inches, centimeters, miles, kilometers. 1 of whichever unit is going to equal 211,200 units on the ground. Okay, so a graphic scale is a symbol representing ground distance. One of the most frequently used graphic scale symbols is a scale bar, and this is something that we are using ourselves a lot in our labs. It's typically a line or bar divided into sections using tick marks or colored regions. As other map elements, there are usually many choices when it comes to selecting the style and appearance of the scale bar. Although it may be tempting to choose a more visually complex version, simpler is generally better, both to reduce visual weight and improve clarity and legibility. So again, this is the most practical type of scale for GIS maps. Also, size changes with the map features if reduced or enlarged. So it would be useful to use this kind of scale bar if this map is going to be reproduced. So measuring on maps, when using a scale bar or a graphic scale, you can use that bar to measure the distance directly on the map. So in this example here, we see that we've taken a piece of paper and created tick marks between 2 different points on the map. And then we could take our paper over to the scale bar with our 2 tick marks and measure the distance between those 2 points on the maps. Sometimes we want to measure distance on bendy things or windy things, such as rivers or maybe a windy mountain road. And so a good way to do this by using a scale bar is to take like a string or something else that's flexible and line it out on whatever you're trying to measure. And then from that starting point to the end point, you could then stretch out your string straight and use the scale bar to find out the distance between 2 points that way. And then if you don't have a bar scale, let's say that you have a representative fraction or a verbal scale, where it says like 1 millimeter on the map equals 10 miles, you'll then take a ruler and measure it out that way. And again, sorry, that was for a verbal scale, not a graphic scale or representative fraction. Okay.